this video, we'll be looking into hazardous occupational noise, which is noise that exceeds the exposure standards for noise in the workplace. It is estimated that 28 to 32% of Australian workers are exposed to hazardous occupational noise at work, with studies showing that up to 4,700 worker compensation claims are made each year in Australia for occupational noise-induced hearing loss. Occupational noise-induced hearing loss occurs particularly in workers from manufacturing and construction industries, in occupations such as labourers, machinery operators, and truck drivers. Occupational noise-induced hearing loss has been associated with other health effects such as increased cardiovascular disease risk, mental health, increased risk of accidents, and decreased productivity. Before we can discuss more about noise, we need to provide some definitions for clarification. Sound is a form of energy characterized by pressure variations which are detected by the human ear. Noise is unwanted sound and is related to a number of factors including magnitude, characteristics, and duration. Sound is generated through the compression of air molecules, with the transfer of energy from one neighboring air molecule to another, creating a ripple effect as it propagates through a particular medium. The sound level decreases with distance away from the source as energy is lost. This is known as attenuation and depends on the medium that is traveling through, for example, solid, liquid, or gas. Detection of sound by humans involves these pressure waves hitting the eardrum as it travels from the outside through the outer ear canal. The eardrum transfers this energy to three small bones in the middle ear. This is then transmitted to the inner ear, known as the cochlea, where the vibrations of the transmitted sound waves are detected by hair cells. The hair cells convert these vibrations into electrical signals, which can be sent via a special pathway known as the auditory nerve to the brain, where it can be processed and interpreted as sounds such as music or human speech. The sound we interpret is dependent on both the loudness of the sound, known as the sound pressure level, and the frequency of vibration, known as pitch. The loudness of sound is measured in decibels. As the human ear can perceive a wide range of sounds, the logarithmic decibel scale is used. However, this means that there can be a wide range of sound intensities between different decibel levels. The level at which we are able to perceive sound is called the hearing or auditory threshold, and for humans this is 0 decibels. Examples of decibel levels of different real-life sounds include whispering at 30 decibels, normal conversation at 60 decibels, traffic at 80 decibels, industrial noise at 100 decibels, and up to 140 decibels produced by a jet engine. In terms of harmful effects, prolonged exposure to noise above 90 decibels results in the development of chronic hearing damage. At 110 decibels, the person will feel discomfort, and above 130 decibels, a person will experience pain and develop acute hearing loss. To explain frequency of sound or pitch, imagine sound moving through a medium such as air, causing atmospheric pressure changes over time. The number of changes per second is known as the frequency of sound and is measured in hertz. How we perceive frequencies is that the higher the frequency, the higher the pitch the sound is perceived by the brain. Next, we'll be discussing the effects of noise exposure, namely occupational noise-induced hearing loss. Hearing loss can be due to a wide host of factors. This could be due to trauma, be present at birth, due to infections, exposure to chemicals or medications, as well as age-related. It can be also permanent or temporary. Hearing loss can be classified depending on the amount of decibels shifted below the normal hearing threshold. A loss under 20 decibels is considered normal. However, beyond this, you can get mild hearing loss, which is hearing loss of 20 to 40 decibels. Beyond 40 decibels, it would be considered hearing impaired. Moderate hearing loss, where hearing loss of 41 to 60 decibels. Severe hearing loss, which is hearing loss of 61 to 80 decibels. And finally, profound hearing loss or deafness, with hearing loss of more than 81 decibels. At this stage, full hearing may not be restored even with the use of hearing aids. Damage to the ear can occur either through a single exposure to an extremely loud noise event, such as an explosion. This is known as acoustic trauma and leads to acute hearing loss. Acoustic trauma results in a shift in a hearing threshold, known as the temporary threshold shift. This condition, with only a single event, can generally recover within 16 to 48 hours. However, with repeated exposure, this trauma can be cumulative, leading to permanent threshold shift. This results in permanent damage to the hair cells of the inner ear. The first frequencies to be lost are generally 4,000 to 6,000 Hz, which is the range required to understand the nuances of human speech. Age-related hearing loss is also a factor that needs to be considered given our aging workforce. Hearing loss can accumulate as we age, with risk factors including high blood pressure, diabetes, and the taking of different types of medications. This means that older workers are more susceptible to hazardous workplace noise. Detection of high frequencies are usually the most affected, as we discussed previously. This may result in the difficulty in determining the source of a sound, as well as the ability to follow a conversation in a noisy environment. In terms of implementing controls to manage occupational noise exposure, it can be difficult, as not only can they come from various sources, occur at different times, but can be affected by worker movements throughout a shift, leading to varying levels of exposure over a shift period. In Australia, the Work Health Safety Regulations describe exposure standards in two ways that need to be met, both assuming a typical work shift of 8 hours. The first states that workers should not be exposed to more than 85 decibels throughout their whole shift. And the second describes a limit of peak noise levels at any point during a shift, and this should not exceed 140 decibels. Employers are obligated to have the hearing of workers tested prior to starting work that would expose them to high risk of occupational noise-induced hearing loss by audiometric testing. This provides a baseline to compare against in subsequent follow-up, which is usually once every 2 years. In terms of managing risk through the implementing of controls in the workplace, we follow the hierarchy of controls that we learned previously. Elimination would be the best type of control, but may not always be feasible, as it would mean the removing of work or machinery which produces excessive noise. Substitution may also be a viable solution by changing or updating work processes or equipment to ones which produce less noise. Engineering controls are generally the most effective way to implement noise exposure control in the workplace. This would involve separation between the source and the worker, as increasing the distance between the receiver and source is important for the attenuation of sound, as we discussed previously. Physical barriers can include enclosing the source using materials which absorb sound, or adding modifications which can dampen sound. Changes in work designs can also be implemented for workers to control machinery remotely at a safe distance. Other controls which should be implemented involve administrative controls. This would involve modifications to work schedules to reduce time exposed to noise hazards, restricting or reducing foot traffic to areas of high noise levels, having adequate signage warning of noise hazards, provide adequate education and training to workers, such as the use of PPE and why it is needed. PPE is the easiest control to implement. However, it should only be seen as a complement to the controls mentioned previously, and should only be relied upon when all other controls are not reasonably practicable. This is because PPE does not totally prevent noise from entering the ear. There are also common issues such as poor fitting, inadequate training, non-compliance, and poor maintenance, which can affect its effectiveness. There are various types of hearing PPE, namely disposable earplugs, ear canal caps, and earmuffs. The aim is to reduce the level of workplace noise entering the ear to a safe level, around 75 to 80 decibels, while still allowing for adequate hearing and communication. In this video, we've gone through a brief overview of the physics of sound and the physiology of how our bodies can detect and perceive it. We then discussed hazardous noise exposure in the workplace and its health effects, namely occupational noise-induced hearing loss. Finally, we talked about the different types of controls which can be implemented in the workplace in order to minimize the risk of excessive noise exposure using the hierarchy of controls.